It's normal or skewed. If it's a little skewed, it's skewed. Like I said, it's like being a little bit pregnant. Yes, you are. So, it's a yes or no question. If it's not normal, then it's skewed. And I'm going to show you how to figure that out, not just by looking at the picture. Sometimes those are kind of hard to tell. So we're looking at skewness. Now the next thing we're going to look at is what's called kurtosis. I know it sounds like a disease. Well, yeah, well, I have to. And well, this is looking at kind of where the hump and the tail kind of move around. Kurtosis, I made up this definition, but it makes sense. You can see this. Curvedness, I also made up this word. Curvedness of a graph. Now, in looking at skew, are these normal? No. Are they symmetrical? No. That's why the hump is pushed to one side or the other. So on these, we're also going to look for that, but they're going to be slightly differently shaped. This is what's called, and we'll draw a little center line. You'll know what that center line is in a little while, how we get that. So this is what's called leptokurtic. These are Latin-based words. So leptokurtic is tall and skinny. Now leptokurtic is non-normal. Right? It doesn't look like a normal curve, correct? Right? It's tall and skinny. But it is symmetrical. Symmetrical meaning if I folded it on that line and folded it in half, the sides would match. Like I said, we just kind of have to pretend if my drawing's on the board. But the idea is it should match. Half and half, that's what symmetrical means. The same on both sides. All right, so it's not normal, but it is symmetrical. Now what we're looking at is what would cause these types of graphs. What this means when you're looking at this graph is, for some reason, things are collected around the center point. So this means it's tall and skinny. So it's kind of like we took the normal curve and smashed it to the middle. All right, so that's what makes it go taller. So it means there's kind of this density that's happening in the middle. And we'll talk about what that means and actually how to measure that. But this is something that's obviously a lot more compacted towards the middle. Now, if we look at kind of the opposite to this, like this. This is platypurtic. So you just think of a plate kind of turned upside down, and that idea of a platypus, you know, that has the long bill that's very flat. So platy means flat. So platypurtic, same thing, not normal, but it is also symmetrical. And this one now is if we had the normal curve and we pushed down on the top of it and it's spread it out. So it's a lot more spread out than a normal curve. There's more spread. This has less spread. This has more spread. Does that make sense? Kind of just looking at them. So on the exam, I'll just tell you it's coming. I'm going to ask you for an example of this. What would make a platypurtic distribution? And what would create a leptokurtic? Both of these. So what will cause leptokurtic, what will cause platypurtic? And you have to give me an example in real life of what would cause this kind of graph. I'm going to give you examples, and you can't use any of mine. Just telling you now. All right? So you can be thinking about this, because if you come up with something, you might want to ask me about it. Like ahead of time, like, will this work for that question? And I think I have it on the handout that I gave you tonight, too. So I like to think of these in regard to population density. And so this would be a place in which people are really smushed into a small area, a small kind of square miles. So I always think of this one as a lot of people smashed in a small area. So they don't live very far from each other. They're basically living on top of each other. That's kind of the idea in New York City. It's not a very big space, but it has a very large population. So we have a high population density, not much spread. The idea. Now, if we look down here, this would be more like Los Angeles County. Los Angeles County, so we'll put on here, we have a low spread. And this has high spread. So Los Angeles County doesn't really have a city center. You know, and they even say downtown, but nobody goes downtown unless you live there. Right? It's not like Manhattan where people go. So Los Angeles is very spread out. So that's why whenever friends, you know, are coming to Los Angeles, like, am I gonna need a car? Of course you're gonna need a car. What do you mean? You can't get around LA without a car. They do have public transportation, but it's not anything like they have in Manhattan. I mean, you can get to anywhere within like 15 minutes, well, sometime of day, on the subway and stuff like that, 15 minutes around Manhattan. LA, okay. You get on the metro line, you get on the bus. It'll take you 2 hours to get from downtown to Hollywood. You know, and to drive it would take you, no traffic, 15, 20 minutes. So that's kind of the difference. You can see how spread out it is. Heaven forbid you want to go to the valley. It's like, there's no mass transit out there. The idea is mass transit goes through it, but not much that stops. So it's very, very spread out. So that's what we're kind of looking at, is leptokurtic things that would cause something to center and be very dense around the center point, with not much out in the tails. And then platykurtic would be very spread out. Now, if we look at a normal curve, and that's what I was talking about last week, kind of is this grade curve. When you're looking at this being normal, obviously it's symmetrical, but the normal curve will have definitions. It will have mathematical definitions to it, which I'll give you when we get a little further on. That'll be on Monday, where we can actually tell if it's exactly normal or not numerically. So when we're looking at this, our book says that a normal curve is mesokurtic. I've also seen mesokurtic distributions look a little bit more like a mesa. Think of the New Mexico mountains. The idea. So the mesokurtic has a pretty wide range of what it's considered, but these are more the extreme ranges of the platykurtic and the leptokurtic. So we would say a normal curve basically has normal spread. Kind of the idea. Just right. That's the idea. Now, why these things become important to us in statistics is that when we're calculating statistics, mostly parametric statistics, we're basing it on that the underlying data is normal. If it's not, and it's any one of these four, whether it be very skewed or leptokurtic or platykurtic, then that messes everything up. And we're not real happy when that happens, because basically we can get a significant difference and it's untruthful. It's garbage in, garbage out, basically. You can do statistics on any numbers you want, it doesn't mean the answer you get is true. So much of that truth in that answer is based on, is it normal or not? So you kind of have to know what you're starting out with. There is some wiggle room in that normal. So they can be a little off normal, and there's some statistics are still fine with that. They're called robust. They'll handle it. But if it's way skewed like down there, you can do the statistics on it, but when you get the output, it's garbage. And people will tell you, oh, just do it anyway. Oh, no, I can do it. It's like putting gas in a car that doesn't run. It's still not going to run. You're not going to pay. I can put it in there. It's still not going to be what you want. So much of it's based on this normality of the underlying data in the curve. And you'll see that for each statistical test we have, we'll have assumptions. And one of those assumptions is based on a normal distribution. So if you know you're starting out with a lot of this skew, you have to do things mathematically or sometimes research-wise, to make it more normal. We're going to have people, and I'll show you some of these when we do the mathematics. There's going to be people who are what are called outliers. And outliers are people who be way out here in the tails and pull it for everybody. Like, they just mess it up for everybody. Right? So these are, let's say this is somebody, like say it's on your test. So let's say there's a score of 100, and there's lots of people who score really high. And there's one person who scores 10 out of 100. Do you see, that's going to bring the whole average down. Just one low score bring the whole average down. Right? And then you say, well, I'm going to base it on the average. That's not really fair. Because it's just one person that brought the whole thing down. Or think of it the other way. Everybody does horribly on the test. And one person out of nowhere, because you're a genius, you know, gets like 100 out of 100. And they're like, well, I just said it by the highest score. You're like, who are they? You know, who got that? There was like, you know, who's the outlier? Kind of stuff. So they are the ones that, and there's sometimes there's research ways we can handle outliers, but sometimes there's statistical ways we'll handle them as well. And I'll show you that. So that's when you kind of have to know the curvedness of what you have and whether or not there's skew. And that'll come up as we go along. Right now, all I'm asking is you to identify the pictures. All right, that's kind of the step we're at. All right, and be able to tell me how those things would happen. So then this would be, just review from last week, this would be a class that had a lot of high scores, right, and not many low scores. Remember bodies piling up? So this is high scores, not many low scores would be an example of negative skew. Positive skew would be not many high scores, a bunch of low scores. Because remember, it's always going low to high. That's what the graph always goes. So this would be a lot of low scores, not many high scores. Does that make sense? Okay. So if I were to ask you, what are the measures of central tendency? This would be your answer. There's 3 of them. We'll go through each one, and they're also in the handouts I gave you. Mode, whose symbol is MO. Median, which is capital MVN. And then mean, which is X bar. Some books it'll be a capital F, but in our book it's an X bar. So these are your 3 measures of central tendency. And they go from least used to most used. And I'm going to show you in various situations what we'll use. But in most of the statistics we'll do, they're going to be based on a mean. A mean that is centered, that is normal. So remember, at the beginning of all your PowerPoint notes for the book, they're going to give you this little rundown of what's in the chapter. So those are always there for you. If you're looking for something, that's the best place to look. So it's got the mean, mean, mode. We're going to figure out which is appropriate at what time. Okay. And then remember, just as a review, our symbols from last time. We have the sigma, which is the Greek letter capital for the S, and it means to add everything after it. And in these formulas that I'm going to give you tonight, you're just going to see the sum of X, meaning add them all. All right? So it drops the I on the bottom and the N on the top. So whenever you just see that sum X, that sigma and then X, it means add them all. Add all the data. Like I said, those notation on the top and bottom drop off very quickly. So that's what we're going to be seeing in some of our formulas tonight and how we deal with that. All right. So central tendency is going to answer some questions. One thing it's going to tell us when we're able to compute that is, are the scores, if we're looking at an exam, for instance, are the scores, did people do generally better? Did they do well on the test, or did they not do so well? That's the idea. They'll tell us indications of that. Is it a high-scoring exam or a low-scoring exam? It'll help us figure that one out. And it will also show us where the center is located. Most of the time when I'm drawing these on the board, you're seeing me draw a line down the center, and that's our measure of central tendency, is that line. And we're going to need to know where to draw that line. What happens on the skewed ones is they're not one line. Here they're one line. What happens on the other ones is you're going to start to see multiple lines because they get stretched out because it's so skewed. Is one. I'll show you what those look like. So we're hoping it goes straight down the center. So that's the center of the distribution. And I'll show you how to find that as well. We're going to have a mathematical center, and we're going to have a physical center, and they're different. I'll show you how we figure them out though. All right, so the mode. The mode's the one we use the least. We really can't calculate a whole lot with it. It's more a descriptor, like a descriptive statistic. And so the mode, and I think these definitions are on your handouts too. The mode is the one that has the highest frequency. It happens the most. So we'll just say the score that occurs most often. Literally, just look for the ones that repeat. And that's your mode. So we're usually looking at this on a nominal scale. You don't use it very much with interval ratio data. I think I give you some examples there on your handout. So I'm looking at the handout. Here, there's the central tendency. And let's look all the way on C on the bottom. Sorry, let me put it here. So it's the most frequently occurring score. So we look at these scores here. And you literally look at which one happened the most. So there's all the scores repeat, the 5 and the 6 and the 7. So you're literally looking at which one repeats the most. So that's how we get the most. The idea is literally just a counting thing. That's why it's nominal, you know. And you should always put the scores when you're doing these kind of things for the mode and the median. Mean not so much for the mode. You need to put them in numerical order. It's a lot easier to see these things if they're in numerical order rather than you counting and just saying some. You know what I mean? So we put these in order, and you can see that you have more 7s. So our mode is 7. Now we can have multi-modes as well. Yeah, so on this one, for instance, on 7, that would be unimodal. There's only one mode. Here, the mode is 4. So there's only one number that's most frequent. You see the idea? So it's unimodal. It just has one hump. That's the easiest way to describe it. Now you can have distributions that have 2 modes. And they're going to look like this. It's called a bimodal distribution. This distribution, the 5s and the 9s both had 3. Do you see how to read the graph? So there must have been 3 5s and 3 9s. That's what caused those 2 peaks in the graph to go up on the frequency side. You see how I'm seeing that? So then we would say it's bimodal. At the point at which you have more than two, it becomes multimodal. We don't go into trimodal, quadmodal, all that kind of stuff. So it's either unimodal with one mode, bimodal with two, or multimodal. Now you can have the situation where there's no mode. What if no score repeats? You have to say no mode. Don't put 0, because 0 means is a number. You literally write out no mode. All right, so no number repeats, no mode. Doesn't have to happen. This is the handout from last week where we had frequency distributions. I'm just going to go down to this one. Actually, let's look at the top one first. You can just look at this one if you don't have it with you. Now remember what each column is. The first column is the actual scores. The 1 through 20. Those are the actual score. Then the F column is how frequent it is. Well, isn't the mode about frequency? Right? So what would be the mode here? That's what you're going to say. It's not 2. And the reason why is because those 2's are not scores. They're body counts. So the mode is the score that goes with the body count. Do you see the idea? So the mode is 15, 10, 9, 8, 7, 6, 5, 4, and 2. It's multimodal. All of them have a frequency of 2. Right? So we're looking at the 2's. There's no 3's. We're really looking for a 3. Because that would have given us one number that was the mode, right? It went above all the others. But all those scores happen twice. It means it's multimodal. All those would be the mode. No, bimodal means just 2. Just 2 high scores. You can have 1 high score, 2 high scores. Any more than 2 is multi. This certainly qualifies for multi because there's a slew of them that have 2. Look, see how the 2 starts down here? And so you have to remember, in that F column, what the 2 is corresponding to are these counts, not scores. So if we're looking at, let's say we didn't look at the scores. Let's say we did this. And we just looked at the tally marks. And I said, what is the mode? Would that make more sense to you? Because it's just a tally mark and we're counting them? I think what sometimes best is shows is another number sitting there. So this is literally the count. There's 2, 2, 2, 2, 2, 2, 2. See how nobody has a 3? Tally mark of 3. That's why it's multimodal. But something in the brain happens when I suddenly make those into numbers. And then, that's the number one answer people will put with this. The mode's 2. No. The mode is a score. The 2's just represent how much those scores happen. The body count. Multimodal, and then if I was asking for a numerical answer, you would list all of those. You would list all the numbers that are there, that have the 2 by them. Does that make sense? Sort of? Little?
So let's say one of them was 3, what would that be?
Unimodal, and it would be just that one number.
Okay. So you would put the score, and you put every single score?
Yes. So you would say, if I said, say it was multiple choice, and I said, is there no mode, unimodal, bimodal, or multimodal? the answer would be multimodal. If I said, what's the mode of this distribution? You just start right. Mode is equal to 15, 10, 9, 8, 7, 6, 5, 4, 2. That's your answer. That's a numerical answer. Those are all modes. They all have a frequency of 2. Did I miss any? I don't think so. Okay? You say so, lady. So now let's look down here at the grouped one. Say we don't know the raw data. That is unknown to you. You can't see the top part of your handout, all right? I just hand you this. And I say, okay, where's the mode? Can you at least tell me the vicinity? Yeah, see these 4s here? That's telling you those intervals have the highest frequency, right? So we know in there is the mode. So now I ask you for a numerical answer of what is the mode. We talked about this last week. What number would you use? You'd use all of them, but there's a specific number for each one of them. You're right, right? It's the midpoint. Remember we talked about if you have to guess, you guess the middle? So if I know that the midpoint's in these 3 intervals, mode is there, then this is going to be 4.5, 6.5, and 8.5 is my best guess of any number in there. Remember it's the center, not the average. How I'm getting at it, I'm adding those 2 numbers and dividing by 2. So on this one, you would, if I ask you for a numerical answer, this also is multimodal because there's 3, and the mode would be 8.5, 6.5, and 4.5. Because those have the highest frequency, and I need one number to represent the interval. Now I'll be the center of it. If you can't eyeball the center of these, you just add both those numbers, divide by 2. And that'll give you the center of the interval. Okay so far? There's more. So this is actually where the mode is. I knew this would happen in my career. I think I told you I have a degree in design. So this is where statistics and fashion design collide. I was sitting in fashion class one day, and I knew it would happen at some point. And there's actually a term within fashion design called mode of the day. And mode of the day is a term that's used by people who are costumers who have to do period pieces, like the movies. Like the person who had to do all the costumes for Lincoln. Like for that movie, it was very popular. Anything that's done historically, they have to go research what's called mode of the day. That means they go look at old pictures, old drawings, anything they can get their hands on, that shows what people are wearing. The problem with that is that the further you go back in history, we don't have those kind of things, right? And if there were drawings done, they were usually of a higher class of income because they could afford the drawings. People weren't sitting around sketching poor people. Well, let's sketch the peasants. No, that just wasn't happening. People would pay to have the portraits done and that sort of stuff. So the further you go back into history, the harder it is to figure out what did people really wear during that period. We really have no idea what the cave people wore. We're just guessing. Right? The cave. Choose just a body count of how many people landed on that interval.
So we're going to do like 2 to 3, 18 and 19.
Why isn't it where?
Why wouldn't it be 2 to 3 or 18 and 19? Well, there's like,
Because there's only 2 people there, and there's 4 people in here. So remember, this is a body count.
so we're looking for the one that has
I call it, yeah, if you're thinking 1 score per person, then it has the highest number of scores.
Sure, we can go ahead for our scores, not just the most frequent. Two would be frequent.
No, 2 is not the most frequent, 2 is the body count that's the most frequent.
Okay.
But that's just because of how we put the intervals. It's arbitrary. So these are not scores, those are not numbers.
But if you're going on body count, like if you're looking for a body count, that would be, okay, the most, right?
If you're looking for, is the most frequently occurring score. So this means 4 people got a score between 4 and 5. We don't know in what combination, right? It'd be 4 4s, 2 and 2, we don't know. Then this group gets, and the next group, 4 people, there's 4 scores in there. The next group, there's 4 scores in there. So those are the most frequently occurring scores, given we put the intervals this way. And this, just look at this one, nothing else. Just at this distribution, 4 is the highest frequency, highest number of occurring scores. These are the scores, that's the answer I'm looking for. Not how many bodies, but the actual score that goes with the body. That's the idea. That's what your tendency is to do. That's why I'm trying to tell you, don't look at it that way. And if you have to, the other way to look at this is to do this. Actually,
Yeah, they put it in challenge mark.
yep, that's all those are.
It looks like
I can do that for a long time. So that's really what those are representing. You may not see it now, but you will in the privacy of your own home. On your home. All right. So let's look at median next. So when you hear about the median in the road, right? You hear about pull to the median. The median down the center of the freeway. The truck has crossed the median. It's always bad. That means little center. It's a little physical center. That's why they call it the median. Literally in the center. And so when we're looking at a distribution, and we're looking at percentiles, show you what I mean by that. Okay, so this is 100%. This is 0. You think of this as 100%. So think of this as percentages. This is 50%, and this is 50%. So if I'm talking about what's here, that's the 50% mark. Does that make sense? Okay. So we talk about the 50th percentile. And these notes are at the end of the chapter 1 notes on percentiles. Percentile means everything below that point. All scores at and below that point. On the, I don't call it graph or curve. So if I am at the 50th percentile, that means 50% of the scores or people so if I'm at the 50th percentile, I'm here, that means 50% of all the scores are below you. All right? So let's say I'm at the 80th percentile. Realize being at a higher percentile is usually better, right? Means you're climbing up. So the 80th percentile, if I'm here, that means 80% of the scores are below me. I'm sitting on top of 80%. So the way I like to draw this, rather than looking at an 80th percentile, would it make sense to you if I said it's about here? So that all this is below the 80th percentile. Think of it this way too. Here's a cylinder with water in it. This is 100% full. If I fill it to the 50th percentile, I'm here. That much is below. Get the idea? It made a lot more sense to me when I did it in cylinders than when I did it on a curve. Now, if here's 100% of the cylinder, and I'm at the 80th percentile, that means all this is below me. This is 80% of the cylinder. Get the idea? So if you were taking a test, would you rather be at the 80th percentile or the 50th percentile? You'd rather be at the 80th. You'd rather be at the 100th if you could. But it means that many of the graph, or that much of the percentage of people or scores or whatever are below you. So you're literally sitting on top of that amount. It's what percentile means. So we always talk about the median being at the 50th mark, like the 50th percentile mark. So that 50% is below and 50% is above. So just realize it's always out of 100. So if you were at the 80th percentile, that could mean you did better than 80%, but 20% did better than you. See the idea? Yeah. So it's always chopping it out of 100%. Okay, so 80th and wherever you are. They often report these scores with various tests. They'll give you a percentile ranking. Now what that means is we're going to compare everybody who took the test around the same time you did. It could be in that calendar year. So they may say, for this calendar year, you scored on the SAT in the 80th percentile. Or if you take it the year before, it might have been the 70th. But it's all based on who took it with you that year. You see the idea? That's why they report yearly percentiles. There's a test called the Miller's Analogy Test, which I hate. I'm not very good at that. And the Miller's Analogy Test is one they require for some jobs, and they require for some graduate schools. Analogies are those awful things like pink is to blue as orange is to blank. You know. And what they don't tell you about that test is it's not always the word, sometimes it's a letter, the number of letters in the word, and that's what matches, all kinds of stuff. So when I took that test in college, you would call in for your scores. It was pre-internet. So I called over to UCR, and I like my test on the Miller, I like my score on the Miller's Analogy Test. She goes, "Oh, are you an education major?" And I said, "Why do you ask?" She goes, "Well, for education majors, you scored in the 90th percentile." I'm like, "Well, pretty good." I'm not good at these things. And I said, "No, I'm not an education major. I'm a psych major." She goes, "Oh." Why? You're only in the 30th percentile psych major. So I'm like, "Oh." Well, and the good thing was you just had to take it. They didn't really care what percentile. I ended up getting to UCR anyway, even though I didn't go there. But they just wanted you to take it. But that shows you, like, and I'm like, that's not good. The education, everybody's becoming teachers. You know, like, their scale would be so different. You see the idea? It's kind of, that means a lot of them are doing really bad, but they're doing really bad together. So the percentage goes up. Yeah. So a lot more psych, this is a lot more psych majors than education majors as well. But that's the idea of percentiles. So you're always kind of sitting on top of whatever number that is. So if you just remember that the 50th percentile is always the median. That's the physical center of the graph or distribution. Now, we're going to use the median when the graph becomes very skewed, because the median is not altered by outliers. It's not sensitive to outliers at all. It doesn't care how weird you are. Right? It will keep its center. So, let's see. Look at the handout that you have again. These examples here go above and promote. If you look at these scores, you have the center, you literally count to the center. You put them in order. They do have to be in numerical order. So you put them in numerical order, and then you go to the center. Just count in to the exact center. If it's odd, it's much easier. If they're even, you have to add them together and divide by 2 to get the dead center. So you see how the median is unaffected by that score of 100. This would be an outlier. You'll see when we do this, the mean is very affected by that, but the median is not. So when you have outlying scores like that, real weirdos in the batch, you use the median. Or you should say unique. When you have unique individuals that have shown up to your experiment or survey, then you use the median. And I'll show you how that compares to the mean, because the mean is very sensitive to outliers, but the median is not. Those outliers are the extreme scores that are there. Okay, so let's look at, go back to this. Now this is going to get a little complicated, but we'll get there. All right, now I want to find the median of this distribution. So let's think about how we might do it. I'll just tell you so you don't have to count. There's 25 people. So we know we have an N of 25. You do not know the raw scores. I'm telling you, just don't pay attention. You would not know the raw scores. So the way I would know my N is I would sum my F column, and that would tell me my N. So if I added up all those numbers, I would get 25. I'm just saving you some math. Okay? So now I need the exact center. So I got to find the center of 25 people. How am I going to find that? Divided by 2, what do we get? You get 12.5. So I need to find out where the 12.5 persons it is in this distribution. I need to find out. So remember when we were doing the floors the other night? We were doing the floors on the distribution to get the cumulative frequency, right? So I'm going up. I need to figure out what floor did the 5.5 person, the 12.5 person get on that elevator? What floor did they get on it? That's what I'm looking. Okay, so let's look. You're thinking between 9 and 10? Okay. Where do you think? 8, 9? How you get there? Okay, we're just going to count up. So you can count up the tallies, or we can do the elevator thing. So you got 2, add the 4, we got 6. Now 6 people are on this. 6 person just got on. 4 more get on here. Yeah, now I got 10. 10 people are on, right? Now 4 more get on, and I have 14. Remember I told you that this 10 is the very top of the interval. So the 10th person got on and the door is shut. Now I go to the next floor and 4 more people got on. That's the 11th, 12th, 13th, and 14th person. Does that make sense? That's who stepped onto that elevator, that floor. So 10th person got on here. Look at this. This is person 11, 12, 13, and 14. So the 12.5 person The 12th person carrying their small child, carrying the baby. They didn't only count as a half. They didn't have to pay for a full seat. Got on the elevator at that floor. You see the idea? That's how I got there. Now I have to ask, okay, I know where they're at. What score best represents that interval when I ask you what the mode is? 8.5. You just went on here. How did you get there? Oh, okay. So now if I know they got on this floor, because the 11th, 12th, and 14th person got on there, I just look over here. Our best guess at this interval is the 8.5. So all you're doing is counting from the bottom. They're already in order, so you just count. So you're going to take however much your n is and half it. It tells you exactly half, so the physical center. Got 25 people lined up. Get to 12 and a half. The center is here. And now you're just looking at, once I pile them on top of each other, how far do they go up? And you could just count. You could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is your 12th tally mark. You know it's in that interval. You can do it either way. You can do it with the numbers here, or you can just make them little tally marks. It just gets hard to make the tally marks when you have 20 and 50 in an interval. Any idea? So what I want you to know from this is kind of how to find out where you are. Like how could you find out the mode from this, and how could you find out the median from this? The mean, I'm not going to have you calculate with this because it takes some pretty convoluted formulas, and no one uses them anymore. So I stopped teaching them about 5 years ago. I hate teaching you stuff you'll never use. It's ridiculous to me. So, but I do want you to, because they're just counts of recognizing where the mode and the median is when you're looking at group frequencies. If you know that much, we'll be good. Then you just count them. That's how you determine the n. So you might want to write after that, count them. That will equal your n. However many you have. If n is an odd number, the median will be the score in the middle position, right? It's always nice when they're odd. You know, right there. And then if the n is an even number, you just arrange the two scores, average the two scores in the middle. So you would just add them and divide by 2. Now something else I want to show you that can happen is, let's say I have this. So I end up having an odd number. So I put them in numerical order, lowest to highest. And the 7 repeats a lot. And so we go to the center, you know, 4 on this side, 4 on this side, and then here's our median is 7. So don't be fooled by the fact there's multiple 7s, right? So I have 4 on this side, I have 4 on this side. So 7 is the median. Does that make sense? Now, I used to, when I was a mean teacher, there's actually a formula, it's a pretty big formula, to interpolate the median. So when you had multiples like this, you can figure out the exact median. It's slightly above 7, but you can get it exactly. And I used to have that be the first formula that people did in this class, but I had so many people drop after that. It's like, maybe that's not a good idea for a first formula. And it's actually not used much by handing forms, we just do it in SPSS. So again, one of those things you'll never use. It is very fancy looking, you know that, but not very useful. So we'll just go with the 7. How's that? So even though it repeats, you would still say it's 7. The problem I'm sure you can see is we don't know which 7 it is. When we say 7, we'll just assume it's the 7 in the middle. Okay? So should that come up, that's what we'll look at. Now we'll look at the mean. The mean's the one we'll use the most. And the mean is going to be the mathematical center. And again, some of the percentile notes are at the end of chapter 1. I think it's about 3 slides. If you want what I had written over here on the slides. So the mean is the mathematical center of the scores. So we have a physical center and a mathematical center. So the median is not affected by extreme scores or outliers, where the mean is very affected. Are you outside or something? And this will sometimes be our reason for choosing to use one or the other. So when we have a normal curve, this being our normal curve, 50-50, with a nice curve like this, we'll be able to mathematically calculate that exact curve. The 50th percentile also fits the mean. So when there is no skew, would mean the mean and the median, I thought you guys were going to party out there, are equal. So no skew, mean and median will be the same number. Yeah, so skew, remember, to yes, full, so that's a hump going to one side or the other, right? So if both the mean and the median are sitting dead center, you know the hump hasn't moved. So both the median and the mean are exactly, and I mean exactly the same number. If they are not exactly the same number, there's a little bit of skew. There could be a little to a lot. You can be a little pregnant, right? Or you can be a full 9 months, right? So the idea is skew or not, it's a yes or no answer. But then how much skew has to do with how far the mean and median are apart. So for instance, when we have positive skew, what you will see when we're going this direction, the median's about here, and the mean is here. The mean is pulled by the extreme scores. On this one, there would be high scores. And this way, the mean is here. Median is about here. So this is negative skew. You should be able to tell skew just by knowing the answer for the mean and the median. So in positive skew, the mean is greater than the median. It's a bigger number. So with positive skew, the mean will be a larger number than the median. When there's negative skew, the mean will be a smaller number than the median. So if I were to give you the mean and the median and say, is there skew? You're like, I don't know, I can't draw a graph from that. You shouldn't have to. You just compare the numbers.
Did you say that the mean is directly between, like, the direction where the graph is going and the mean?
It's not always in the dead center between them. It's just the way I draw it. But the mean is always pulled by that tail. If that makes sense. So in essence, this is average. Okay, we'll do what they tell. This is average income, with Bill Gates included. All right, so Bill Gates is an extreme outlier of income, right? Billionaire. So that, if we added Bill Gates' income to all of our income, it takes the average income and pulls it way high. In fact, every man, woman, child in the United States makes about $50,000. if you add in Bill Gates. All right? So we're all very wealthy when you add him in. Okay, so now let's add in instead of that, but see how the median stays about the same. So the median's still almost center of the graph, and it is mathematically the center, but the idea is it's not pulled so much, it stays in the center. So do you see how there's, depending on who's going to tell you the income of the United States, depends on what they want to do. Are they going to report the mean income or the median income? The mean income is actually quite high because we have a lot of billionaires in this country, right? So if we add them in, that skews the mean in this direction. Right? It's pulling it up higher, makes us all look very wealthy. There's a lot of rich people. So the average income goes up. If, however, we look at median income, which means number of bodies at 50% and 50%, that median income, because there's so many people in this country who have no income, even if you count people over 16, working age, its actual median income is about $10,000 a year. Now, if I want to create more programs for the disadvantaged, for people who are not working, which one of those do you think I'm going to report? The median, because it's so much lower. All you're going to hear me talk about, average income. You think I mean average, but average actually can describe the median or the mean. It's a central tendency, so it can be the average. See the idea? So your next question is talking about average. You should be going, whoa, median or mean? And they're like, where'd you come from? Because they hate when reporters do that, right? And so that's kind of the idea. It's kind of know what they're saying. If they're reporting mean versus the median, there's a reason for doing so. One serves their purpose where the other one does not. And usually the mean is the one that's going to be very skewed. So think about, this would be, let's say we base the class on the average score, and that sets the grade curve. And you have a person who gets 100 out of 100. You see how everything just got pulled, right? If you've got really, really low scores, everything gets pulled down on the average. So if I say there's 100 points on the test, and the average, the mean average was 50, you don't know how many are above or below that, because it's a mean, right? It's just an average. You don't know. That could have been one person who got 10. Cause the whole thing to be pulled down to 50. You see the idea? But if I say it's a median, I have 100 points, and the median score was 50, that means half of you got above 50, and half of you got below 50. So it's a real different. The mean doesn't tell you anything about how they all kind of stack up on one side or the other. It just tells you the mathematical average is all. So that's kind of why now, when they look at average, they're asking about your income and a lot of things, they won't look at your average income. They ask you your high year and your low year of income. See how that tells them a little bit more about that? And so it's always kind of like, well, when I was a student, you mean? Did those get counted in? When I was first getting out of college and we did income taxes, because you realize when I was in college, I was making $3,000 a year. And then when I came to JP, went to $18,000. I was like, whoa, happy day. I was like, I'll take it. So what, imagine what they did in income taxes at that time, right? You go from 3,000 to 18. They used to allow you income average. They don't allow that anymore. But used to, you could average 3 years of your income for 1 year. That helped me so much that first year. Because I could do, it was like 3,000 plus 18,000. And you just take, divide by 3. I was doing, that's good. For income taxes, it was lots. I didn't have to report as much income. They took the average. Then I think they realized how much money they were losing. So we're not going to do that anymore. Yeah, no. So, there's all kinds of ways this can be used. You just got to think about which one, for descriptive purposes, is doing what you want it to do. All right, so let me show you how to calculate the mean. So we're looking at the exact mathematical center. And again, we're using interval ratio data because we can add them up and divide. And the mean is going to be used in situations where we have a normal curve. Because you can see how deceptive it is when it's a skewed curve. Add up all the variables, add up all the scores, and divide by n or how many you have. So you can see the I on the bottom and the n on the top have dropped off. So that means add them all. And this is just a mathematical average. Have you ever done averages before? That's all it is. Just as a thing to your name now. And we'll use that symbol of X bar. Symbol for the mean. We will use the median and the mean the most, just because the mode isn't used very much. Now, in a perfect normal distribution, this is a very specific distribution. Perfect normal, they all sit on the same line. All three of them sit on the same line. In a normal distribution, we're just looking, for our purposes, we're really just looking for the mean and median to be the same. For it to be just a regular normal, not a perfect normal, just a regular normal. We'll be fine with that. So we're not going to concern ourselves very much with the mode. I'm going to ask you to report it, but that's about it. You're not going to do anything else with it. As long as you can find it, know what it is, those frequently occurring, you'll be good. But we're actually going to be calculating medians and means quite a bit. And we're going to compare those to see if they're skewed. We're going to compare those to see which way it's skewed, if they're not the same number. Is it negative or positive skew? So I would commit those things to memory, about the mean being higher or lower. And sometimes what would help you, if you forget, draw just a number line. See, not a curve above it, just a number line, see which side. The mean is always on the side of the skew. Can you see that? So see how the mean's on the positive side, the upside. Here, it's on the negative side. That's how you should remember it. If I would just draw a little number line, set the median, and see which side the mean's on. Right? Positive skew. Negative skew. It looks pretty hard. The quick way to do it. Here you can see his drawings of it, of kind of where the mode hits. I tend to usually just draw the median and the mean. But his skew isn't as extreme as mine. You can see how it's pulled. Remember, the tail is being pulled by the extreme score of the outlier. Those unique individuals among us. Let me write down. Now see the idea. So the mean is always very affected by the outliers. It's pushed and pulled pretty easily. Now these next batch of slides, I'm going to let you go through on your own. So it just shows you examples of them. Here it shows you some of the graphs, which we've already gone over. And then it will give you, just like on the problem set, these are just more of the same. Where it gives you numbers and it says find the mode, find the median, so you know those are in there. But I have a lot like this on the problem set as well. All right? So just know there's more examples in there. So with all of that, I'm going to start the first couple slides at 4. So let's just double check problem set 2. If I didn't cover my notes, it's in the book in chapter 2. Yeah, you can do all problem set number 2. This is what you were hoping for your weekend. We're going to do that next. We're going to start a little bit on standard deviation and variance. We're going to do a lot of it next week. It is part of problem set number 3, yeah. It's all of problem set number 3. I don't think so. I don't think it is. And I think you should be able to do it without the board. the complement to our lovely measures of central tendency are measures of variability. While the measures of central tendency, and I'm going to raise this, I know it's hard for you to see down there. The measures of central tendency tell you about skew. The variability is going to tell you about the kurtosis. The idea. So variability can also mean dispersion. And it also means spread. So how spread out are the scores? And we're going to have, there's several of them, but we're going to go over range, standard deviation, and variance. Don't think those are the only ones, but those are for our purposes. And this idea of dispersion is how spread out are things. There's a normal amount of dispersion under a normal curve, so it's normally spread. That's why it's called normal. It's normal spread. Leptokurtic, remember? Not much spread. It's really tall and skinny. Okay, folks, that's only an hour when you're looking at that long. Leptokurtic is the tall and skinny one. And then platykurtic, well, it looks like the plate turned upside down. So this would be low variance or variability. This one would have high variance. High, just think of it as spread. Now the way I've always thought about this, and always helps me, because I personally relate to it, think of it as hip spread. So, I will never be a leptokurtic woman. Let's put it that way. I've got much more than a platykurtic thing going on. So the idea is you really think of it like a hip measurement. We're going to talk about secretarial spread. It's very sexist, but it does help the visual. So the idea is it's spread out of a hip measurement, right? That's high spread. That's high variability. Low spread. All right? So if you ever get confused about those, just think of hip spread. Works great. Right? That's literally what it is. Spread out. So high variance means high spread, and low variance is low spread, or thin and narrow. So that's really what we're looking at with variability. Dispersion is another, I was actually taught to call them measures of dispersion rather than variability. Dispersion is actually how do things spread out, but it's more of a chemistry term. And we look at dispersion rates of chemicals. We look at, what's Dexter? You look at the dispersion rate of blood splatter on a wall or on the floor. See, they actually do measure those. That's how they can tell velocity of a bullet has gone through the human body. They can look at the blood dispersion pattern and actually from that dispersion calculate the velocity and where it went through the body, just by how that spread. So they actually, there's mathematics and all of that. I have a friend who works for LAPD and underground, and they calculate dispersion rates in case a nuclear device goes off anywhere in Los Angeles County. So it actually have calculations, they have a computer calculate that if this size of a, say, a suitcase nuclear bomb went off in downtown LA, what's the dispersion rate, depending on how much of a chemical was in that bomb. They have a pattern for all over Los Angeles. And because, the reason being, when it occurs, if they know how large it is or whatever, they can calculate how much it's going to spread out in what time. They are going to block off that area, you know, with National Guard and with police, and no one is allowed in or out. So they will not allow first responders into that dispersion pattern because they know everyone's going to die in there anyway. And they're not going to send their first responders in to die. The idea. So that's it. And chances are, well, what if you're trying to get out? You're dead anyway. You're not going to be able to get out, is the idea. And so they have these built on calculations like the weather, where the mountains are, how many buildings are in an area, all that in these dispersion pattern calculation. And somebody in the day class, they asked me, "Do they have this for Rancho?" Probably not. They don't care. They're probably doing it for Ontario Airport. They probably don't over here. They have in large metropolitan areas. See the idea? And don't think we're the only ones calculating them. Tara's calculating them as well. There was no, when you think about why would someone set off a bomb at the Boston Marathon finish line? That's where the most density of people would be. Do you see the idea? They're not setting them off like at the 10th mile. You know what I mean? Because there's not as many people. So it's the same thing of calculation of an area that's condensed, where people would be. You see the idea? It's the same idea. They're looking for density, they're looking for low dispersion, and maximum damage. The idea. So you look for where there's a lot of people. So that's, I don't think they're calculating those, but that's what they're thinking. You know, in their head, it's like where the most people are going to be. I'm looking at a leptokurtic area. Where would that be? Finish line, right? So the grandstands are and everything like that. So that's kind of the thinking. You just don't realize there's names for it, you know, and statistics. But you actually can't calculate those things. Now, he's always told me, if I call you and I say, you know, like, are you in LA? Yes or no? Where are you? Leave. Don't. There's no questions. Just get out. Okay. You know, I hear you. So I'm in downtown LA a lot. You know, people say, is that more dangerous? Not really. Because there's not a whole lot in downtown LA, if you're allowed to. There's not a lot of people there. Where do you think the most dense area is in Los Angeles?
LAX.
No, it could be, but that varies so much depending on the time of day. Staples Center depending. Staples Center, LA likes a new dispersion pattern because it's getting so many people down there, like they had a concert and they have Staples Center and all that. It's actually Hollywood. It's actually that intersection right there at Hollywood and Highland. That's the most dense area right now in Los Angeles on any given night. I know, not a place I go often. Steer way around there. You know. And so, yeah, and you see how those would change given on what they build there and all kinds of stuff, so they've had to change those all the time. And that's how they also change, where the people are, that's how they also change where they send the officers to on any given time. They look at population density and what things are going on. So there's people, my mom used to calculate that for sending no sheriff's department. Where do you send the people power? Where do you send the officers? Depending on the crime rates by any given week. So she would tell me, you're not going over here. Usually, I grew up in San Bernardino. She used to go, "What neighborhood you grew up in there?" She goes, "Yeah, don't go there." Oh, okay. High crime rate now. All right. You know, so that's the idea of variability. What we're looking at is measuring that and all these numbers. All right. So again, I'll give you this little rundown of what's in the chapter and how to compute that. We're just going to do the first couple of slides. So there it is. Variability is spread. So how much do the scores differ from each other? The more they differ, the more spread out they will be. Let's look at this one. So here's our three distributions. Just looking at these, which one do you think has the most variability? A, B, or C? I'll tell you my son's like that. So A has the most variability because it's the most spread out. See the 0 to 12? So basically, it goes from 0 to 12, where B is only 4 to 8. See how it's real basic? Just that's range. So tell me from the highest to the lowest. And then in C, they're all the same. So what happens when we look at a graph like C? We're looking at, is it really like, say here is 6, and I have people who get 6. You see how there's almost no variability? All the scores were the same. So this actually has 0 variability because they're all the same. See the idea? So more variability is literally what causes, this is low, variability, not much spread. That's a kurtosis would be leptokurtic. This would be a lot of spread. Does that make a little more sense? So we're looking at, okay, so you can kind of see it goes from low, medium, and then kind of down to normal at the bottom. And different statistics can handle it being a little bit less than normal. We'll talk about that. Some can handle it better than others. So this is exactly what I just told you, so you know it's in the notes. So smaller variability means the scores are more similar. They can even be exactly the same. They're closer to the mean. It's a tight squeeze, around the mean. And there's less distance to the score. So let me show you what I mean by the less distance. So we start looking at standard deviations. The deviations from this. If this is my house here, and my friends live close by, these are where my friends live. Does it make sense if I said they all live kind of near me, there's not much spread? Right, I don't have to drive very far to go pick them up. I see this is a good thing. All right, they're all living kind of close. Maybe not so much for family members. So now, if I look at this, and here's my house, and now here are my friends, and I'm having to drive this far. I'm driving a lot farther. The idea is what I mean by the distances. It is literal distance when we start talking about these of spread. Literal distance out from the center and from each other. So think of it as driving distances from the center. Sometimes that'll help you to think about it. If you ever look at personal ads on a lot, not that any of you do. If you're looking at it, a lot of people will say, it'll say things like Santa Monica and 10 miles distance only. So it's like, okay, gee, I would like to meet this guy in Santa Monica. It's like, where do you live? Upland? Where? Then you go, Ontario, Canada. No. Now, Upland's like, well, that's a little geographically undesirable. And what geographically means undesirable, it's too darn far to drive, and I don't think they're worth it. It's too far. There's a guy I went to high school with, hadn't seen him in like 20 years. Kind of funny, he lives like within 2 miles of me for the last 10 years. I'm like, really? How bizarre. But I wouldn't have seen him at some point living in the same city. You know what I mean? You just think it's so small, and you don't. All right, so look at range first. So the range is very simple, and we don't really have a formula for this. So there's a specific way you can write it on your formula sheet. So we'll write it over here, and I'll just leave it up here. So you can write range, the actual word range, because there is not an abbreviation for it, and capital R means something else. Your range is equal the high minus low. So you can write it that way on your formula sheet. One of the few word things I'll let you have. So it's just the highest, you can't write high score minus low score. That's getting a bit much, right? You can write high minus low. All right, so if we go back to these two examples, we're looking at the median. If I do the range on this, so if I want to do the range, I'm going to take 100 minus 5. And on this one, the range is 10 minus 5. So I get a range of 95 and a range of 5. that math? Does that make sense? So just by seeing the 95 and the 5, just by seeing math, and I said, which one has higher variability? What would you say? Yeah, the 95, the bigger number. So the bigger number means more, just like a hip measurement. Bigger number, more spread. That's it, it worked. Bigger number, more spread. And a lot of times that's what we're doing is just comparing. Like which has one more or less, that kind of stuff. The higher number is always more spread. Uh-huh.
Would it be all right if we said, oh, the range is from 5 to 3? Or is that?
Is what?
Would it be okay if we said the range is from 5 to 100?
No. Well, it could be if you need to, in your head, calculate that way, but the actual range will be a physical one number, like a 95. When it's saying what the range is in statistics is different from saying how the numbers range. I know it's weird, because we're saying the numbers range from 5 to 100. That's actually a different statement than saying the range is 95. I know it's weird. I said, the English part of this never makes sense. Okay, but no, it will be an actual number, and I want those numbers subtracted. Right?
We're basically gonna subtract the highest number from the lowest.
Yeah, you subtract the lowest from the highest, yeah. That's it. That's all you do. No, you're gonna wish they were all this simple. That's how we do the range. It's the simplest one you will do. Okay, now we want to do the standard deviation, variance and standard deviation. Yeah, so I want to explain these a little bit to you. Oh, you can't see this, can you? There you go. Now you can. The variance is really for comparing graphs and comparing distributions of scores. And the standard deviation is what we use more often. It's more concrete, where the variance is much more esoteric, in the sense that we can calculate it with the number, but it's very difficult to draw. I will never ask you to draw a variance of 20, for instance. You can't do it. We can, however, draw standard deviations, and I'll show you that when we calculate. So I think you get the idea of this versus this. So would we be in agreement if we said this one has more spread or more variance, right, than this one? So then if I said, okay, what does that mean numerically? It's S squared, the variance. Just an S is standard deviation. You'll see this on the slides in a minute, but I'm going to give this to you now. Okay. So S squared is equal to 20. S squared is equal to 5. This one will just be a bigger number. That's kind of how you do it. So if I said to you in a question, if I said, okay, so the pictures you can tell me. Now if the pictures go away, and I said, I have a distribution with a variance of 20 and a distribution with a variance of 5, which one has more spread? The bigger number. That's all you really use variance for, is comparing against each other. We have to get it into more workable units so we can actually draw them and compare them, and that's standard deviation. Okay? So variance is more of just knowing if it's low or high is good enough, and then we're going to actually calculate standard deviation. Because variance is actually like a three-dimensional thing, so it's kind of hard to draw if you flat surfaces. So we're going to use standard deviation much more than variance. So you need to know how to calculate them both. All right, so show you how to compute these. And I'm going to give you, on the next slide, just warning you, is a definitional formula. And I give it to you only to show, because it'll be in every stat book you ever see, but I'm going to show you a different way to calculate it. So when you write this down, this formula should not be on your formula sheet at all. This is just to explain the concept, not how you calculate it. Well, you can. I mean, it's up to you. But you don't have to write it down. You're never going to use it in that regard of actually calculating. So what this is showing us, what it's meant to show you, is that literally each, just like I was showing you here, we're looking, so here's the mean in the center. How far is each score from the mean? Which is what that says. You know, subtracting each one from that. I'm then going to square it and add it and divide by how many I had. I'm literally getting, remember these were distances to my friend's house, right? By driving distances, I'm getting an average distance. I'm getting an average deviation. So let's say these are my friends and I want to charge them all the same gas money. All right? It's not fair that one lives in Palm Springs. Right? So I said, all right, what I'm going to do is I need an average amount that I charge all of you. Y'all okay with that? Yeah, we'll all pay the same amount. I need the average literal distance they live from me. Right? Don't I have to get that to make them all the same? I'm going to charge them miles per gallon, like an average of that. So I need a literal distance. So I need a standardized deviation. How much do they deviate from me? It's literally an average deviation. But deviations, how I want you to think about them, is distance. They are physical distance from the center. All right, so deviation means how am I from my center point? How much do they deviate? If I have a friend who lives in Palm Springs, she deviates a lot from me, from where I live. If I have one that, I live in Upland, so if I have one that lives in North Upland, maybe she just deviates a little bit. It's a literal distance that you're driving along the number line. If it's a negative deviation, guess which way you're driving? That way. You go negative on the number line. If it's a positive deviation, go this direction. It's literally like you're moving along the number line, is how they work. And it will tell you exactly how far to go along it. And that's what we're going to be sitting on, is moving along that line. So I have, so as you can see, variance is the squared, and standard deviation is not squared. Variance between these two, people get confused a lot. Just remember the variance is always the bigger number of the two. It'll always be the larger number. And let me give you, I'll just give you this one. We're going to do a lot of these next week. I'm going to give you the S formula first. And I'm going to give it to you, explain it in pieces, but then we'll have it next week in more distinct steps. And if you've ever had to do the formula that way for 200 scores, this way is a lot easier. That's a different color pen here. This one, in the first set of brackets, says square each x, then add. Can you see that? I know sometimes it's difficult to see. So the square is on the x. So you square it first, then add them. This one says something very different. This says add all x's, then square the total, then divide by 10. And put brackets around that. So you do those two things first. Doesn't matter which one you do first. So on this one, I'm going to take all my scores and square them, then add up all the squares. Most of the time, your calculator will do this for you. Do that all over again. You just take the s that you have and you square it. It is literal. It is s squared. You've already calculated the s. Just one more button on the calculator. Okay? So don't go through all that again. You're likely to make a mathematical error. And this will take some doing. The reason I'm giving it to you now is I know some of you are ahead, and you can actually start doing this on problem set 3 if you wanted to. But I'm going to do a bunch of examples of this on Monday. All right, we're going to do one in class. Huh? It is. You just didn't know what you were doing. So I gave you a lot of these on the summation work to get you used to seeing them. Yes, I did. You're like, this one's kind of familiar. Yeah, you just didn't know what it was. I was getting you ready. That's the idea. So yeah, you should see these, like, can you tell the difference between this and this? And that's when people get confused the most. So take some practice doing them. And remember, this one doesn't have the parentheses, this one does. So sometimes that helps.
So once you solve the formula and you get the second condition, you square it and you have your variance?
Yes.
So we do the formula sheet, can you tell us what it stands for? Like-
No, you just have the S. Yes, you wouldn't have the name of it, you just have the S. Nor can you have this except in simple form. Yes, you should have this form. Now, to tell you what some people do. What some people do on their formula sheet, like instead of doing this, see, I don't do these, so we might have. So they're saying square them, and then add. I never use them. But you can't put a 2. You know, I know a lot of people use it though. You'd be really surprised. Then over here, it would be, this one would be more like add. So you'd add first, and then times. A lot of people do it that way too. You just can't put a 2 there. Yeah, you put arrows. You can't put any numbers at all, except for the ones that naturally exist. So these are fine. They already exist in the form. You're just going to add extra. So you can't use number examples on your formula sheets. So we're trying to get this symbolic side of your brain. So you know what a square is. A square is a number times itself. So this would be squaring each number. It's the number squared by itself. You actually just put a dot in here so you want to. That works better for multiplication. That helps. So they're multiplied by each other, then add. So anything like that is fine. Do you have to do that? No, I never use it. Yes. You just square the answer. So to get the variance, we'll say to get variance, just square your standard deviation. Now, if I gave you the variance, let's say I just told you this, and you had no other information, how am I going to square it? Square it. I like the unsquare term though. So now if I wanted to get the S to be equal, they're interchangeable. Either way. Usually, the way you go about it is you calculate the standard deviation because that's what you use the most. You don't need the variance that much, then you just square it if you need the variance. But you usually have to calculate the standard deviation, you might as well. And just know that the very last thing you always do with the standard deviation is square root it. It's not on this first quiz now. No, I usually don't give you mathematical things on the quiz. They're usually definitional stuff. Yeah. Now, I could ask you this in words though. I could say, given you know the standard deviation, how would you get the variance? And it would be this is a multiple choice answer. You see what I mean? It's more of a concept than in the actual numbers that you're doing. But you get enough on that of the problem set. So I try to use the quizzes for more definitional concept kind of stuff. And try to get the questions and the answers to match on my key. Some of you email me. I got those all straightened out, I think. I had put a question where I changed the answer, forgot to change the question. And I've got 20 people take the quiz. Some people just they guessed it, got it right. But other people are like, I don't know, let's pick something. And so I went back in and changed I should have emailed everybody. I went back in and checked and changed their answers. Then I changed the quiz for everybody else. So if you haven't taken it, you won't know this. But those early birds got all my stuff. So I went back and changed the score. So this is just showing you that the deviation is, the variance have to do with how the scores, how are they around the mean. If you actually, it's kind of a weird thing, if I were to add up these distances, right, what do you think they'd add to? Anybody want to hazard a guess? Anybody in my green section want to hazard a guess? A very green question I'm looking at. Huh? Yes. If I add up all these distances,
Then I
Would be like the variance?
they'll go to 0. Who said that? Yeah. Very good. It's 0 because remember these are negative, these are positive. That's why we have to square them. When the distances all go out, it's away from the mean. You push them all back together. They center on the mean. If I add all these up, they all should go back to 0. That's why we have to square them. In order to get a number, don't leave you 0. Square them and divide by this. They all end back up at your house. That's the idea. That's why they have to go back to 0 point. No. No. Those aren't formulas. You see what she's asking me? She's asking, can I write something like S2 equals B and S equals S? No. Those aren't formulas.